Drop it.
Welcome back to another video. In this video, I'm going to demonstrate to you another implementation of a two-dimensional array in Java, trace matrix. In linear algebra, a trace of a square matrix A is defined by the sum of the elements of the main diagonal A. I have here an illustration of a trace matrix. As you can see here, what we're going to do is, first, there must be an equal number of rows and columns here. So in this example, we have a 3 by 3 matrix. To get the trace of a matrix, what we're going to do is we're going to compute for the diagonal value of the given array. So here we're going to compute for row 1, column 1, row 2, column 2, and row 3, column 3. Now, let's say we have a 3 by 4 matrix. So what we're going to have is it's not a square matrix. Only values that have the same number of rows and columns will be considered as a trace matrix. Before I discuss the code, let me run first our program for you to see the output. Now here's the output of our program. Let me resize this one first. Now, it's asking us to enter the order of matrix. So let's have first a 3 by 3 matrix. Now let's enter 9 elements. Now, the given matrix is this one, displaying 1 to 9. And the example that we provided is a trace matrix because number 1, the rows and columns are the same. Then we're going to get the value of row 1, column 1, row 2, column 2, and row 3, column 3. So diagonal, we get the sum of the diagonal numbers here, and the sum is 15. So let's try it again. Okay. This time, let's say a 3 by 4 matrix. Let's say not 3 by 4, let's say 2 by 3 matrix. 1, 2, 6, enter. Now we have here the given matrix 1 to 6, and it gives us the output which is not a square matrix. Okay, so let's now go to our code. Now the first section here is we're going to define our array. So we have the following array: I and j for our loop, x and y for the order of matrix, and then a for our array. Then I have here another variable which is t, which will be used to compute for the, let's say, sum of the diagonal values. This section here allows us to prompt the user to enter the order of matrix in which we're going to save it to the variable x and y. Then we're going to inform the user to enter the number of matrix. Next is, this is our input. Okay, this is our input wherein we're going to store the value of x and y to our array here to be represented by array I and then array j. This section here allows us to display the order of matrix or the given matrix that we have. And this is how we identify whether it's a trace matrix or not. The first requirement, if we go back here, is that the number of rows and columns must be the same. To do that, we have here a condition wherein if x is exactly equal to y, let's say a 3 by 3 matrix, what it does is it will perform this loop and then print out the trace matrix here together with its total or sum. If the value of x and y is not the same, then we're going to have this, it's not a square matrix. Okay, so we have this loop. The loop here will scan for the values, go each of the array elements here. Okay, it will read all the array elements. Then we have another condition. In order for us to get the sum of the diagonal value, we have another condition, that is if I is exactly equal to j. So what's I and j? I and j here will be the numbers of rows and column. Okay, if we go back here, this will be I and j. Okay, row 1, column 1, row 1, column 2, row 1, column 3. So since row 1, column 1 is the same, 1, 1, we'll get the value here. This one here for row 2, column 2, and this one here for row 3, column 3. So once we have that equal, so we have to identify here the rows and columns must be the same, must be equal. Okay, then we store the value to t. Then once we have able to finish the loop, we print out the value of t here. So here's an implementation of a two-dimensional array, which is the trace matrix. Hope you like the video. Thank you for watching. Bye.